For this operational amplifier circuit shown, we're asked what is the phase of the voltage gain in degrees of 29 megahertz and we need to assume that the op amp is ideal. We have these resistor and capacitor values here. And for this, we're going to turn to the notes that are linked below the like button. In page 28, we have differentiators. And previously, we've looked at one with like a capacitance up here, but now we look at one that's in series with our voltage input. So at high gain and at high frequencies, we see that we are going up from being down here. We have some notes on it here. What we're going to be using to analyze this is right here for the frequency domain. We're going to be looking at the bottom part here. So our frequency domain, we're going to plug in our values. We know that our omega is going to be equal to 2 pi times the frequency, and then we can just plug this in. So we have negative j times our 2 pi, and then our frequency is going to be this 29 megahertz. And so that's going to be 29 times 10 to the 6th here. And then we're going to multiply this by our resistance. And then the resistance here is 1.9 kilo ohms. And this might differentiate from, if you have a different problem, it might differ. But that's basically, we're just going to be using this equation. And next we have our capacitor, which is 6.7 picofarads. So we're going to have 6.7 times 10 to the negative 12th inside of here. And so once we have all of this laid out, we're going to get approximately negative j and then a 1.9533. And so this is going to be the value here. This is more or less of a step 1. In step 2, what we're going to do is plug this into our to get the frequency, because currently it's in a rectangular form. We have 0 minus j 1.9533, and to get the phase angle, it's going to plug into a tangent -1. We're going to have the imaginary number over a real number, and our imaginary number in this instance is going to go right here. Now our real number, remember, it is 0, but we can't plug in 0, so we have to plug in something that's basically 0. It's going to be like 0, 0, 0, 0, 0, or 0.0000, tons of zeros, and then a 1 here. And then if we do this, we're going to get about negative 90 degrees. So that is how we would get negative 90 degrees for this, going off the notes that are in the description.